Okay, good afternoon, everybody. So we are starting a new industrial talk that is sponsored by IEEE Security Systems Society Chapter Rio Grande do Sul, and also Council UNIDA, IEEE Council UNIDA Chapter Brazil, also with the support and of Federal University of Rio Grande do Sul, Brazilian Computer Society, Brazilian Microelectronics Society, and ABSEMI, that is the Association of Semiconductor Industry in Brazil. So today we have the pleasure to have here Osvaldo Correa, that is the Microelectronics Division Director of TSA Brazil. So Osvaldo Correa is PhD student at UNICAMP. He has a master's degree in technology process from University of Sorocaba, and he holds a bachelor degree in engineering of control and automation, and holds a degree in physical. He has more than 30 years of experience in electronic and microelectronics, having started his career at Sistemas Automotive in São Paulo, and he has also in 90 was promoted and become development engineering chief. In December 93, he started his own business at Prodau Automação in Sorocaba, Brazil. In 2009, he joined the GMO auto parts industry, Ipero, São Paulo, and as development engineering manager. In 2013 until now, he works as TSA Tecnologia in automotive systems in São Paulo as a microelectronic division director. And today, Osvaldo will talk about the development of thick film electronic devices in the current scenario. So thank you very much, Osvaldo, to accept our invitation. And I will give you the first I'm going to put your slides in the air, and then I'm going to give you now the control to start your presentation. So you have the control now. So thank you again.
Thank you, Professor Reis, for the opportunity. It's a pleasure to be here and have this opportunity to talk about thick film technology. Since 10 years ago, I am involved 100% with this technology. This is my day. Every day I work with that. So it's an honor to be here. Talk about that. Thank you very much.
Thank you.
So today we are talking. Our theme today is about the development of thick film electronic device in the current scenario. So to summarize my presentation, I make it easier to understand. I decided to divide in 3 topics. Firstly, we thick film technology. First, we begin with thick film technology. Then we are talking about the market and current scenario. So we are involved in this problem of coronavirus and the possible opportunities in the market. And end up with the examples, application examples. With this slide show, thick film technology, I put many pictures on it just to try to show you, to make it more easy to understand. I put here in this corner a heater using a substrate, metallic substrate. We have examples here that we have a thin film. We are discussing, I had deeply about this, the difference of thick film and thin film. So this is a high integrated circuit. Probably you know some of one could know what is thin film. Thin film is related to semiconductor technology. And you have it here, for example, in this high integrated circuit, you have here chip on board. This is very low on the market. In the middle here, we have a ceramic MEMS. This is a pressure sensor, especially for automobile industry. In the right in the middle, you can see here bridge, a small bridge, a resistor. This is in ceramic, we call it piezo resistor MEMS. So by this side in the middle, you have an antenna. This is wearable sensors that is also making in the process of thick film technology. And this corner here, I just leave some electrodes that they are using in medical devices. This is a special one. We are further ahead. We are discussing deeply about that. This is a product that the TSA produces. It's 1.5 thousand million parts a year we do produce at TSA. This corner here, we have a special shape, is a tubular high voltage resistors. That's also manufactured using thick film technology. This is just an overview of the whole world of thick film technology. I just did this slideshow just to show what is thick film technology, where we have this in our day. So what is the question coming always when we are talking about thick film or thin film? The people just asking us, what is this? What is this technology? Why they call it a thick film or thin film? Oh, this is the problem. We have a limit of this value. We have here, we have a line, a limit line. When you have some device, that no matter the technology using to produce, if it's sputtering or whatever, it's silk screen, the process doesn't matter. This the definition take care about just the definition. If you have a layer, a deposit layer thickness greater than 1 micron, you call just a thick film. When you have a less than 1 micron, the deposition layer, we call as thin film. So, like I told you, it's you all. This is not. They don't take care about the process of the manufacture. This is another example. This here, the technology. We have a thin film is a transistor process. Then here I have a layer to make easy to understand. This is a thick film. We print a layer like you have in thin film, many layers. This is like a planar technology. So this is almost the same, but for sure it's not the same. For thin film, you have a process. There are big differences in dimension, because for thin film you have nanometers. We are talking for a transistor. We say this is, we can have 10 nanometers, 3 nanometers from drain to source. As a big difference. We are talking when we say we are working with thick film, the thickness of the layer is about 10 microns. This is normal. So the dimension difference is enormous. So this is another one. This is the people just talking. I have it. I see many papers. There's the people are talking about it, thick film and thin film. They make some comparison, compare each technology, each other. Actually, thin film and thick film are not a competitor to each other, as would you think. Instead, they belong together. They depend one from other. This is an example. Thick film is a technology, a robust technology. As you can develop them, you can develop some kinds of sensor for harsh environment. You have it's a difference. If you have, for example, here amplifier or memory, you have to have the substrate where you can put many components inside. It's a hybrid component. You have a die, wire bonds connect, and you have some devices, SMT devices here on the substrate. So if you analyze this device, we can say that we have a substrate, then you have 2 wires, 2 dies with a die bond, then we have a wire bond connected to a substrate made with thick film technology. That you can make this substrate also, this device full, complete with thin film technology for sure. But this example here is special for this. Then we have on the left side, we have a pressure sensor developed. This is, you have a die for conditioning. Then you have some transistor and resistor here. This is a main special pressure sensor. This is a capacitive pressure sensor developed. But you have both technology. This technology is not competitor in each other. It just works together. There's a technology work just together. Here's another example. I don't know what happened here because changing the image. Sorry about this, but we have this is if you open your car today in the compartment of engine compartment, you have this special sensor is a fuel pump pressure sensor, and is a special one. I took this picture from a sensor here. We have a SMD capacitor. You have a die in the middle here. Then the substrate is a alumina substrate. I don't know if you can see here, but this is you have in the edge here some tips. This is because it was cut with laser trimming. So this is a typical hybrid pressure sensor because we have two technologies. You have a thin film technology. This is a die. You can see here the wire bond connected to the die. So it's a typical, we call this kind of sensor is a hybrid pressure sensor using both technology. So this is very applicable in automobile industry. So we'll go a little bit deep in this technology to make it easier to understand. I will talk some about the process of thick film, or thick film process. So the process begins with like in the thin film technology, starting electronic CAD design, where you design special patterns for your sensor, and the screen printer. Then in the electronic CAD design, you when you finish your project, you have you generate the Gerber file. With Gerber file, you become the screen. It's a transparent stencil. With the stencil, you make the screen printer. Then you put in the screen printer, you print, you have the device print. Then you should dry this device. After that, you should fire, that you should synchronize it. And if you need it, for example, for this kind of application, for example, for fuel level sensor that you needed to trim and to adjust each resistor, you should have the process of the laser trim. We have two of them here in TSA. So for pressure sensor, for example, you have to adjust to leveling to balance the Wheatstone bridge for a pressure sensor. Then you needed to have also a laser trimming to balance this the sensor bridge. Then we are finished that, you can print one more polymer to just protect it, layer. Then you package it, then you can send it to our customer. This is just to explain a little bit about the process, each phase of process. It's very important, each one. And this is special for this kind of technology. So with this slideshow, I just show you that it's not for technology. We can use it for many kinds of substrate. I told you before that you needed to use it in furnace to synchronize it. But you don't need to have a furnace if you use, for sure, a polymer, and you cannot put in 1850 degrees. It is 1850 degrees is just if you use a special paste for that, this for application like we use it here for full level sensor using aluminum substrate. This is just specific for that. If you use, for example, PET, polyethylene, you probably use 120 degrees to synchronize, not 1850 degrees. Polymedia also, this is the same. You have to use 140 degrees probably. There is in market, define your application or substrate will be the application specific. For example, for the medical device, is very used in the market to have a PVC substrate. They use it to develop some electrodes or sensors using PVC. And for PVC, you don't need to have a simple furnace with the temperature, for high temperature, you burn out all the sensor. Okay, just as an example, with this example here, I would like to show you that the paste will be determined for the application or whatever substrate you're using. We have alumina, you have aluminum nitride, silica glass, PET, polycarbonate, polymer, or metallic steel, stainless steel, or aluminum. You could print in many kinds. This is just some example for substrate. The paste also, like I told you before, is you have the substrate, you define application, you define it for you, the substrate you are using. Special substrate, you need to have a special paste. So I just wrote here paste or ink. What you define it as is paste or ink is the viscosity of the paste or the material. If you have a high viscosity, we call it paste. If you have a low viscosity, we call it ink. So, but the process where we are using this material will define if you need a paste or ink. If you have a screen printer, for example, like here, if you have a screen printer for using a substrate, we have a high viscosity, we have the behavior is a pseudoplastic behavior. For this application that we use for example, to produce full level sensor, we have this behavior. We can have a minimum width 15 microns. Like when you reach that, it's not so easy, but we can do that. This minimum space between fingers or traces of 15 microns. The thickness, we can reach it from 2 to 100 microns. So, like I told you before, if you have, for example, to paste or ink, I just want to come back with this example. So if you have a process of aerosol printing, you need to have a low viscosity. If you have inkjet, you have to have some viscosity, but not so like we have for ceramic substrate, because we have a screen print needed to have special behavior, just a pseudoplastic behavior, and you have a high viscosity. Here, you don't need to have that. This process will define this, the ink behavior. Okay, laser print is the same. We have in the market a special. They are using this in unit, not in the street. For prototype, this is a 3D from a lab from 3D that you can use also for thick film. So, what I would like to explain here is thick film technology is not dependent the process of a screen print. You can use many others process to produce devices with thick film technology. Okay, this is normally the people say that for thick film technology we should use a screen print. It's not dependent that this is wrong. We can use another. This is thick film. We have many opportunities. There are some continue printer system like for photovoltaic polymer. You can use it, thick film technology also, and you don't need to use screen print. This is just one, okay? After you print, using paste in this any substrate that you define, you should put this device on a pure dryer, to be dried, sure. And depending on the type of substrate, like I said, in application, it can be made by dryer with a thermal wave near infrared or ultraviolet. That's because for PVC and the polyimide, there are many inks in market that you have a solvent that is sensible on ultraviolet. Then when you need to use this kind of ink, you should have a special dryer for that. Here in TSA, we have just for infrared. This is enough for our paste, the paste that we are already using for our product. If in the future we needed to have, or we have opportunity to develop a new product using an ink that is sensible to ultraviolet, we needed to buy some new dryer to work with that. But just that, just to know about this. This is our sintering furnace that we have here in TSA. This is the picture that I took yesterday to put in this presentation. Is a environment controlled cool furnace. I will explain why. Environment controlled cool furnace is very important for our product because we have many chemical reactions that will affect our product characteristics, because it will affect the electrical, mechanical, and the thermal characteristics if you don't take care with the airflow inside this furnace. If you have to develop, for example, let me tell you some. If you want to develop some sensors, for example, using a graphene, you cannot have oxidizing environment inside because you will destroy your device. Then this sintering furnace, this is because we call this is an environment controlled cool furnace. You can control that. You can put another gas inside, and where you will not have oxidized environment. This is very important equipment. So after curing, you can, like I told you before, you depend on the product, you need to adjust the value of the resistor. So you needed a laser trimming system. This is a complete automatic laser system. You can see here, this is a vision of this part here, where you put the substrate. It is here the substrate. You can see here. This will have, I can say this is have 1, 2, 3, 4, 7 by 4. This is 28 sensors here. This is a matrix. This is four lines for 7 columns here. You have 58. Then you have a step repeat. Can you see here the probe on probe card? And you measure each one, and this is a laser system that we call as active laser system. You measure and you cut or adjust. There's a trimmer is different. You vaporize material. This is because we call it as a trimmer. And with this trimmer, we adjust the value of each resistor. You have like a motherboard with 28 sensors. You adjust here automatically. You adjust here. This will make a program on the monitor with the operator. Then you put there. You adjust all sensors. So we begin the second part, and this part we demarked will in the current scenario. I put some picture here to remember that we have coronavirus pandemic. We have a problem in the economy, lockdown. We have many problems here. Just to remember the scenario that we are now. Talking about automotive sensor market, this year we have a forecast for 18 billion US dollar for this year. This is just a forecast. This is, I was looking on internet. I just found this number, but I don't believe that we will reach that because we have this I'm a little bit supposed to when don't have that because we have the coronavirus pandemic. Then we had a lockdown from many companies. Probably we don't reach that, but the provision for 2022 is forecast for 2022 it will be 20 billion US dollars. Just for this market, this just a number we will see. Just to make an idea of what we have as a market. The electrical and hybrid vehicle in the sensor market. I just put some sensors here. I think in the left side here, I put just a picture. We have 13 sensors. From these 13 sensors, it's just, we'll keep it independent of if we have electrical car or hybrid car or fossil fuel car. This doesn't matter. Just among classical sensors like fuel level sensors, pressure sensors, chemical and magnetic sensors current used in fossil fuel vehicles will face the impact of electrical vehicles. They will remain small in short term. I don't believe totally about this test, but because if you have a car, this is in the engine, you have many sensors. We'll discuss further ahead, but just to make sure in the electrical car, you increase some sensor for current, for control the load of the battery, or either we have a fuel cells with hydrogen. You need to have many sensors. The pressure sensor for hydrogen, you need to have a flow. You have to control the load. You increase many sensors. So this is that. Here, the development with this slideshow, I would like to show you the challenge that we have in Brazil to develop some sensors. Developing a sensor is quite challenging. It requires understanding a diverse range of subjects. Trying to balance the customer needs or wants versus the trade-off advantages can be difficult. Many customers don't want to share real value and push the price down, giving to lower price goals. And moreover, the local demand is divided among 3 suppliers, then thus make it even more difficult to become viable, the development of product. This is real. This is our real situation today. It's very difficult to do. So could it be worse that we have more government trade agreement? The Brazil-Mexico Automotive Agreement increased the difficulty to provide a sensor solution locally due to the special reduced tax tariff accorded. The high tax rate on imported materials becomes still more difficult to produce sensor locally. This is almost unbelievable. This is, we have this problem now here. We are on discussing with the government to change some tax here. It's crazy. This is unbelievable. I'm not here to talk about this, but it's a big problem in Brazil. The taxation is crazy here. Develop the automotive sensor challenging. I don't like to say, this is 2 words for me, so it means here like 2 ways. You could be in the market, optimist or pessimist. Right? I don't like to see the global sensor market in a digital way, as being only just 2 options, which are optimistic or pessimistic angle of view. There is a middle point of view where you can reach a calculated risk when you can navigate even with some turbulence and still grow up at moderate and stable rate. Yes, I do believe that. I am an optimist by choice, so that, but this is basically it's a really challenge to develop sensors in Brazil. Thick film technology, then we reach the third part. This is a thick film technology application examples. We will show here many examples of application in many areas. I would like to do that. So in this slideshow, I'm trying to show you many sensors that we have in a car. It's not, there's a many because it's not all. This is just for thick film technology. We have just one sensor here that is not made using thick film technology. This one here, this is a magnetic sensor. And wheel speed sensor also is not made, produced with thick film technology. It's a Hall sensor. And we have here 13. From 13, we have 11 is produced with thick film technology. This is in polymer. You have here, this is, I cannot see, this is a mirror sensor. This is for position. This is feedback sensor for mirror. You have acceleration pedal angle. We have a headlamp sensor, chassis level sensor, motor position sensor. Almost all here is a strut position sensor is on polymer. So heat and ventilation, air conditioning sensor also is this thick film sensor, steering sensor. It's about all. It's a fuel level sensor. This is our main product. Like I told you, is 1.5 billion parts a year. We produce that by TSA. As you can see, we have many sensors there. Because from all this, it doesn't matter if you have an electrical car or hybrid car. We'll keep this sensor in mind. Many people asking me, oh, you close your company because you just produce fuel level sensor. Yes, but TSA does not produce just fuel level sensor. We do produce many others. We do produce speed sensor, many kinds of sensors. We have the market. The market is much bigger than we are here. It's no problem. We are able to produce now. We just need to have a chance to produce that. The technology that we have makes us able to produce all of these sensors. Here there's a problem because automotive pressure sensor, if you take this slideshow as a reference, you will not like to, if you work with thick film, because from these 4 sensors, this is just pressure sensor. You have air condition, you keep for electrical car, if a hybrid car. It doesn't matter if we are using battery or using they are using fuel cell, hydrogen. Is this no problem? You need to have air conditioner. But if you have a hybrid vehicle, you still use all of them because you have fossil fuel engine. You need to have all this. But the all other you don't need. If you have electrical car, you just keep this one here. So on this slideshow, I just want to show you all kinds of sensors. Almost all. This is some of them. Actually, in the car, we have about 74 sensors. 74 sensors. This is a middle number. Some car could reach 100 sensors. Just to have the idea. Here I show you this sensor. This is a NOx sensor, just to show you that by piezoelectric principle sensors. This is thick film technology. We do produce that with thick film technology. This is a special paste. This is piezoelectric, not piezo resistors. Thick film technology, actually, we have many others. You could have magnetoresistive paste. You could have a piezoelectric paste. You could have piezoresistive paste. With with those kind of paste, you can produce many kind of sensor. Depends on your imagination, just that. So more two sensors. This is a fuel pump sensors that are usual today. New cars, so we are still produce this kind of sensor. Air condition pump pressure sensor. So I just put here because we produce this one here, some prototypes for Brazil. So the stick film technology application examples, we have a heat fuel level sensor. Again, this is a special one. Just to have an idea, this on my picture here, I can see here yellow. I don't know if what color you see here in your monitor, but we have about 14 resistors here. Each one we will be trimming to adjust the right pattern, just to make you see in your panel the right value of the volume of gas in the tank. This is very important. We needed to control each part of them. This is a hybrid integrated circuit, just an example of the application. We have a die inside them. You have a microcontroller, some capacitors, and it was printed here, some resistors, and adjusted by laser. So this is ceramic MEMS, microelectromechanical system SEMS. This is a quick film. You can see here inside in the middle a bridge, width on the bridge. This is a pressure sensor for industrial automation. This is oxygen sensor. Is made with a special paste. This is for oxygen detection. So for the market of medical devices and sensors, I see the pandemic, coronavirus pandemic, as an opportunity. Sorry about this, but we needed to see that. This gave many opportunity to develop many sensors. So because for the needs of the remote attending, telemetry transmission become essential. Rise up strongly the demand, becoming a great market opportunity for this kind of device. There are many companies in the world exploring this thick film device just to make some equipment that you can bring it for a farm, for some places far from the city that you cannot have a doctor. So a doctor anywhere in his house connected to internet, and you have a device in where you are, in farm or any place you are far from the city. You could be have some help to diagnose your problem. This is because I see this pandemic that we have, coronavirus pandemic, as an opportunity. You could, using thick film technology, you can be easy to have idea in the lab, to bring your idea to the market, because it's very easy to produce that. You needed to have some investment, but it's not like a thin film. So here I just want to show you the drop sense. There are many sensors. This is a big company. This is a Switzerland company. They produce some electrodes for medical devices and sensors, biomedical electrodes and sensors for many kinds of applications. This is a big one. Just to show you, this is a thick film technology. They produce sensors and the electrodes on substrate, in ceramic substrate or PVC or whatever. There are many markets for that. There's electrodes for medical devices also and sensors. Here I just put that to show you. This is like you can see between the finger here. This is a flexible sensors. You can have a good response. This is made using graphene. Here another one also using graphene also. This is made on ceramic. But you can make it as in many applications. Sorry, this is not. This is in polymer sensor using graphene. You cannot use another one. There's this special electrode for medical device and sensor. There's a multitask biomedical measure device. You can measure pH, conductivity, dissolved oxygen, and you have a temperature with a platinum. They use a platinum paste special for resistive thermometers. This was made in substrate of aluminum substrate. To be special, you have 4 measurements here. Here another application for thick film technology. This is some balloon for RF transmission. We have power resistor, inverter brake resistor, and high voltage resistors. This is a high voltage resistor. This is a tubular shape. And you have here especially, you have a substrate, metallic substrate, where it was printed a resistor over them. You have a good dissipation, you have a high power resistor. This is for some of them we use for brake in an inverter. So this is a good example for a domestic application. This is for the stove, the heater for domestic stove. This is a heater. This is a thick film technology over steel. It's a special application. The paste is based on nickel paste. This is a special one. We developed a special application for that. This is a 0.6 millimeter thickness. The power of this heater is about 100 watts. You have a dimension of 10 millimeters by 20. It's about that. It's very thin. This is 0.6 millimeter thick. Another application for heaters. This is on steel. You have a tubular shape. For a special application, for example, heating water, so warming water. This thick film technology allow you to develop devices to be shaped on a steel substrate for heat applications. This is also made using a process of thick film. These are flexible. Before we have a hard substrate, ceramic, steel, and now we can use also thick film technology using a flexible substrate. You can have a potentiometer, heaters, using just, this is a polymer. This is polymid, a special material, polymid, and it's a flexible potentiometer and heaters. You have many applications for that. In automobile application, domestic sets for many applications. So this is some samples of highly integrated circuits, a special package for telecommunication. And so here you can see also the die, wire bond, and you can see also some devices, some SMT, we call the device SMD, some surface mounted devices on the aluminum substrate also, you can see. We call in mark this a highly integrated circuit. So we thick film technology also inside the solid oxide fuel cell. This is a fuel cell. This is a kind of fuel cell that has been trying to be used in car. So it's a kind that we are trying to be used in a car, in electrical vehicles. For solar cell, also thick film technology used to connect its solar cell together. This line here is this is made with thick film technology. Also, is made with screen printed. Use silver paste to do that. This is a good example for thick film technology. For the LED light, also we have a special application for using thick film technology. This is not metal core PCB. This is a thick film. The difference is that in metal core you have aluminum substrate, but you have a epoxy layer that's make not good heat conduction. So when you use thick film process for that, you have a special isolation material make as from glass fried. Special phase for this is a very good heat conduction. Has very good heat conduction. Then you have a more efficient dissipation process. So the final message. So we reach the final for this presentation. The difficulties, we have a message to do that. The difficulty lie not so much in developing new ideas as in escaping from this one. I like this because it's very difficult. You develop a new idea, but you don't want to leave the old one. There's a big problem. And to have a new mindset, new mindset means new solution. And the society is just waiting for new mindset. The world is looking for new ideas, for every kind of knowledge. We are in the right moment to change the world. Then leave your own small world and think bigger. Think your world. Be more open. Share your ideas. Thick film technology is an easier and cheaper way to bring your ideas from the lab to the market. Think about it. We are here, closer to you, with the high expertise to help you to overcome this challenge. Be sure that. If you think that it's hard to do it, let's do it together. Thank you. That was. Thank you very much. Professor Reis.
Hello?
Hello, Professor.
Yeah, sorry, I have a problem with the microphone here. So we have already some questions. So the first is by Professor.
So thank you, Osvaldo. Let's wait a little bit so that Ricardo's back.
I'm back.
I guess now he's back. So Ricardo.
I had just an audio problem, then I restarted the window. So by the way, first question is by Professor Rafael Brum.
Okay.
So Rafael Brum also we have technology because this is the main responsible for all our video conference system broadcasting by YouTube. So first question of Rafael is, do you provide SPICE models or any other sort of model or of your thin film devices to your customers?
So, Professor Rafael, for thick film that we are produced right now, we don't need to have a special software for that, any simulation, because 90% of our product here is a thick film, not 14 film. Then we developed just a special sensor for automobile industry. We have 80% of our market share is just for the fuel level sensor. This fuel level sensor is made with a ceramic substrate where you have a resistor printed over that. You don't need to have a special software. Some of the products that we have in the past, we use the Altium software, just that. that is Altium. I think you know this is a special ECAD for PCB. That's enough for application. And when we needed to have a simulation for some special integrated circuit that we needed to use, even if we use a die, not in packaging. So we have from the manufacturer, because the special software to simulate that. Because in the automotive industry, we have a special integrated circuit. It's customized because we have some standards, especially for that. And we need to attend that to produce that. And, depending on not to develop a new IC or so like that.
So a second question by Professor Rafael Brum. Do you simulate your manufacturing process using TCAD or TCAD-like tools? If yes, how does the actual device performance correlate to your simulations?
Rafael, sorry to say that, but our process is very simple. We don't have any simulation for that. Don't need to have. This is because I trying to show you if I have the opportunity to talk more about thick film technology. If I could go, I don't know which university you are, but I could go to your university to make a special presentation about thick film technology, because it's much easier than you think. We don't need, if you design a special integrated circuit, you need to simulate each phase. For thick film technology, you have the 8 phase. It's very simple. It's a process of screen printing. It's very simple to do that. We don't need to do that. In some cases we do that, but we don't need a special software to do that. It's just we have some tools here, special tools developed by us that we use this to simulate, but you don't need to do that.
So I have a question. Some of the applications are in flexible material.
Yes.
In this case, when you are exercising some flexibility of the material, how you do to not cut the lines and some.
So you mean the substrate?
Yeah, if the substrate is flexible.
Yes.
And then we print.
We print in the all phase many sensors, and then when you are ready, you synchronize it in a dry or furnace. When it's ready, then you stamp. We cut is a special tools for that. Separate all sensor point. That's what it means. What you mean? It is.
Well, I'm meaning during the use of a flexible support, and then maybe if you stress the flexibility of the material,
yes.
Plastic, for example.
Yes.
And then maybe the lines of the connected to the sensors and so on, how yes. They don't cut when you do some this stressing.
Yeah, for sure you cut if you over stress them. You have a limit of elastic limit. There's just we just inform our customer that you can make some tension on the limit of maybe 10 newtons or 20 newtons, not more than that. You have a limit of elastic limit for this kind of sensor. That's what you want to know, or?
Yes. So because I think, I suppose the material that you are using to print must also have some flexibility, no?
Yes, the sensor, the material. For example, it doesn't matter if you use a polymer, what kind of polymer you use. If you use a ceramic substrate, in the case of a pressure sensor, you have a limit of elasticity. You have a limit for pressure. Over that, you exploded the membrane. This is for all material. This is a physical limit.
There is a question by Luiz Carvalho sobre a dissipação de calor. O que recomenda? Aumento da espessura do substrato?
Então, depende. Na verdade, assim, Ricardo, Luiz, né? Luiz. Na verdade, assim, eu não sei o que você está usando. Normalmente, se você aumentar a espessura do substrato, com certeza você tem mais massa. Isso é física, né? Na verdade, assim, você aumentando a espessura do substrato, desde que esse substrato seja um substrato bom condutor de calor, com certeza você vai dissipar mais potência nele, em calor, X joules a mais. Isso você vai calcular em joules, dissipação de calor. Mas o que eu quero dizer, com aquele material que eu descrevi, existe, por exemplo, para LEDs, se a pergunta foi só aumenta a espessura, já recomendo com certeza, tá? Desculpe, se a pergunta é só a preocupação focada nisso, dissipação de calor, o que recomendo? Bom, se você aumentar a espessura, ok, mas não necessariamente ele vai resolver. Na verdade, se tem que tomar cuidado que dissipador está relacionado à área de dissipação. É por isso que os dissipadores, normalmente, ele é aletado. Se você perceber, quando você fala, é feita extrusão de alumínio, os dissipadores têm aletas, porque a área de dissipação, lógico que ele absorve, ele tem uma parte mais espessa, então ele tem aletas. Aquelas aletas, se você somar a área dela, por isso que ela é toda, como que eu vou explicar para você, é toda dobrada, toda tem um processo em cima dele, tem uma área muito grande, e aquelas aletas têm um porquê. Quanto maior é a área, mais ele vai ser simples de dissipar. Na verdade, você não quer um acumulador de calor. Se você tiver um substrato espesso, simplesmente ele vai acumular calor. Legal, ele vai tirar do seu semicondutor e vai trazer para o corpo dele, mas ele precisa dissipar isso para o ar. Então, só ele ser um dissipador, ter uma espessura maior, não necessariamente ele é mais eficiente. Ele teria que ter uma área grande para dissipar esse calor, para não ficar nele, ele passar para o ar e voltar a baixar a temperatura, porque ele vai estar absorvendo do seu semicondutor todo o calor. Eu respondi a sua pergunta, era isso que você esperava?
Bom, uma outra pergunta minha aqui é como é que está aí as possibilidades aí de utilização dos filmes finos aí na área médica aqui no Brasil?
Olha, na verdade,
tem
professor...
muitas aplicações que vêm de fora, né?
Sim.
Mas qual é a possibilidade para a indústria brasileira aí ter uma participação maior nesse mercado aplicado à medicina, né?
Na verdade, nós temos aqui, devido a eu estar fazendo o doutorado na UNICAMP, no CCS, eu tenho contato com muitos pesquisadores. E esse é um trabalho que eu estou fazendo, tentando trazer para a indústria muitos projetos que ficam guardados na gaveta ou simplesmente se transformaram num paper ou até numa patente, mas na verdade não se transformou num bem para a sociedade. Isso é uma preocupação e transformar num negócio também, né? Lógico, uma coisa lucrativa. E normalmente quando você trabalha com team film, a gente fala assim, team film é sempre focado. Quando alguém fala de team film, o pessoal fala semicondutor. E na verdade tem, eu diria, quase que milhares de sensores sendo desenvolvidos no Brasil. Eu tenho dezenas aqui próximo da gente, tanto no CTI aqui próximo da Unicamp e na própria CCS na Unicamp, que eu estou trabalhando junto com eles em várias frentes para desenvolver sensores e mandar para o mercado, inclusive para a área médica. Eu não posso falar muito detalhes sobre isso, porque nós temos o NDA que amarra isso, então eu não posso dar muito detalhe, mas sim, com certeza. E nós estamos trabalhando em cima disso. É um dos meus trabalhos aqui, é correr atrás disso aí, transformar em negócio esse tipo de produto. Mas temos sim, com grafeno, estamos trabalhando em cima disso. Com semicondutores, tem um monte, tem muita aplicação mesmo. E eu estou vendo, eu sou otimista, como eu disse na palestra, eu sou otimista por opção, por escolha, e eu acho o seguinte, na verdade, existe uma carência no mercado, existe muito conhecimento na universidade, isso que me impressiona, com o meu doutorado eu vi isso, existe muito conhecimento, mas estão nas gavetas, e isso me decepciona um pouco, eu esperava que, na verdade, não acontecesse isso, eu não sei se é por falta de interesse das indústrias, mas me deixa até chateado, porque, na verdade, existem muito boas ideias, mas muito boas ideias mesmo. Só que, na verdade, às vezes as empresas lá de fora acabam descobrindo isso antes da gente. Eu não sei se a indústria tem medo, ou é a linha dos pesquisadores, eles ficam receosos por causa da indústria, mas existe uma certa barreira aí. E eu quero vencer isso, por causa do meu doutorado, está facilitando essa aproximação, e eu estou bastante otimista, eu posso falar para o senhor.
Eu endosso um pouco essa sua colocação aí, Osvaldo, que hoje aqui no nosso caso, aqui em Porto Alegre, a gente tem mais facilidade de cooperação com indústrias no exterior do que no Brasil, né?
Sim, infelizmente é assim.
Aí eu vejo 2 pontos. Um primeiro é que nós temos um número pequeno de indústrias, né?
Sim.
Que também estão sempre lutando com um excesso de burocracia, resolvendo coisas do dia a dia.
Impostos.
E, por outro lado, há uma falta de incentivo, né, a que as pessoas que estão fazendo pós-graduação possam criar suas empresas, né? Os sistemas de incubação de empresas no Brasil ainda são muito... Né? Uma coisa que a gente vê os colegas lá no exterior é que capital para começar uma empresa não falta, né?
Sim.
E aqui, infelizmente, as coisas são muito mais complicadas, né? Então, essa interação universidade-empresa a gente tem que aumentar muito mais, né? Nessa área que... Né?
Sim, o que não faz sentido, né, professor? Na verdade, assim, por que não aqui? E, na verdade, quem gera imposto é a indústria. Isso que eu acho, assim, na verdade, eu sempre falo assim, que é um círculo virtuoso. Se eu pego o conhecimento da universidade e transformo em valor, gero mais imposto, vem mais dinheiro para a universidade, gera mais conhecimento, volta, quer dizer, na verdade, assim, quando eu converso com o pessoal da Alemanha, que eu viajo para lá e estou conversando, eles falam assim, eu não entendo o seu país, é estranho, cortou verba para a universidade, cortou conhecimento, como que vocês querem sobreviver? Vocês vão importar todo o conhecimento, é isso? Como que vai funcionar? Eu não consigo entender isso, eu tenho dificuldade. Se eu conseguir explicar isso, por favor.
O que a gente tem visto nos últimos anos aí é cada ano um corte sobre o que já foi cortado no ano anterior.
Sim, é isso aí. Como que pode isso? É inaceitável, eu não entendo isso, sinceramente eu não entendo. Quer dizer, na verdade, se a indústria está mal das pernas, como a gente fala na indústria, se a indústria está mal das pernas, ela não consegue faturar, ou ela fecha. Se ela fecha, eu acabei de matar a galinha dos ovos de ouro, porque, na verdade, eu poderia gerar mais impostos. Na verdade, a minha visão é, sei lá, eu sempre vejo assim, que, na verdade, assim, como existe mau pesquisador, existe mau empresário. Existe, entendeu? Tem que tomar cuidado, lógico, mas, normalmente, uma empresa séria, na verdade, ela paga os impostos dela. Então, esses impostos geram mais recursos para o governo. E se ele gastar bem, nunca vai faltar dinheiro para a universidade. Isso que eu não entendo, essa falta de dinheiro é uma coisa assim que eu sei disso. Aqui em São Paulo, bom senhor sabe. Tem um monte de universidade aqui quebrada, porque está complicado mais ainda agora que cortaram as verbas. Então, mas infelizmente é isso, né? Eu não gosto de falar de política, mas a gente deve falar às vezes como a gente conversou antes, né? Mas é complicado.
Mas, já que a gente transformamos aqui o final num debate... Sobre essa questão, eu vi há pouco tempo aí um exemplo muito claro disso. É um slide produzido pelo Ministério da Economia, né, cujo título era O Rombo das Estatais. Tá? Que, no meu entendimento, o título deveria ser Investimento nas Estatais. Né? Então, apareceu a CETEC lá embaixo, que é um investimento mínimo, né,
isso
muito
é um assunto
aquém do que deveria ser.
Sim.
E como primeiro dispêndio aí, que estão considerando como rombo, era a Embrapa, né?
Sim, como que pode? Como que
Qualquer
pode?
um de nós que não é da área sabe que o desenvolvimento do agronegócio no Brasil, né, é devido ao suporte da Embrapa e em novas pesquisas da Embrapa e das universidades, e que esse investimento, que não é também muito grande, o resultado que o Estado ganha aí de impostos devido ao desenvolvimento do negócio é outra ordem de grandeza do que o pouquinho que é investido.
Sim,
então isso aí demonstra uma falta de visão macroeconômica de ecossistema, que é a mesma coisa que está acontecendo em relação à CETEC, né?
Sim, com
falta
certeza.
de visão estratégica, né, da importância de investir em algumas ações que vão resultar no desenvolvimento de todo um ecossistema industrial,
Sim.
sem contar depois todas as aplicações geradas por esse ecossistema, né? E todos nós sabemos aí que nessa área de tecnologia aí com a internet das coisas, né?
Sim,
Vai estar tudo conectado com sensores, com dispositivos que tem que cada vez consumir menos energia, porque não vai ter geração de energia suficiente se não houver otimização.
Concordo,
né?
Perfeitamente, sim.
Mas...
na verdade, uma das linhas de pesquisa, eu tenho contato, puxa, estou tentando lembrar o nome, inclusive ele fez palestra, teve ano passado na USP, nós participamos, né, a TSA foi patrocinador do evento na USP, e nós tínhamos um stand, eu cheguei a conversar com, acho que o diretor do CETEC, ele fez a palestra, esqueci o nome dele, aqui no IEEE, aqui.
O Eric?
O Eric, isso. Eu conversei com o Eric pessoalmente lá e ele estava conversando comigo, porque eu tinha o stand da TSA, eu tinha os produtos lá, e daí ele estava falando a parte de sensores, que tinha uma linha da CETEC trabalhando só em cima disso, para a gente até conversar, e nunca deu certo. Daí começou o Covid e acabei não descendo para lá, mas eu vou descer uma hora para conhecer aí. Eu gostaria de conhecer a CETEC.
Quem quer conhecer um pouco mais sobre a CETEC aí, a primeira palestra dessa série nossa aí de Industrial Talks foi justamente da CETEC, e a palestra gravada está disponível no nosso canal YouTube da IEEE CAS Rio Grande do Sul, né? E foi já acrescentada ali também a palestra da HT Micron, né? Aqui de São Leopoldo,
também
já foi colocada lá, e todas as outras palestras que foram feitas até agora nas quartas e sextas-feiras, elas foram gravadas, né? Não estão todas ainda ali na página do YouTube, né? Devido a que está havendo uma sobrecarga de trabalho aqui da equipe nossa aí, mas em breve elas devem estar aí disponíveis, né? Todo esse elenco de palestras que foram gravadas aí, né? Então eu gostaria de agradecer mais uma vez aqui ao Osvaldo pela ótima palestra, muito interessante, né? Aqui no chat do YouTube tem muitos aí dando os parabéns. Aqui o último deles é o professor Jacob Swart,
meu orientador.
Então,
obrigado, professor.
Agradeço a todos que assistiram essa palestra, que virou um quase debate aqui no final. Né? E então agradecer mais uma vez ao Osvaldo.
Eu que agradeço, professor.